So this will be one of many discussions that we have that revolve around math and C++. Well, because math is pretty complex and I can't put it all in one video. But we have to start somewhere. So let's start with the basic arithmetic operators like addition and subtraction and whatnot. Now, C++ is capable of all sorts of fancy stuff when it comes to numbers, and we'll tackle these things as we become a little bit more fancy ourselves. And so let's start at the very beginning, shall we? And so let's add some stuff, and let's jump in super aggressively because it's just like you expected. So we can say C out to the screen, 3 plus 4, and then drop down a line, and then no surprise here, we should get a 7, and there you go. Now, the problem with this is that the calculation that was performed here is lost. We didn't save it to anything, and so if we ever want to see the result of 3 plus 4 again, well, we have to actually run the calculation 3 plus 4 again. And so more common is to create some sort of a variable. Say we create this integer variable, call it a sum, and we say that sum is going to equal to 3 plus 4, and then we just see out sum to the screen instead. And then when we run this, well, we expect to see another 7 because, well, we just added 3 plus 4 in 2 different ways. Well, you can also use variables on this side of the equation. So if we had this integer a, say, and a equals 8, and we had this integer b, and b equals 4, well, we can take sum and make sum equal to a plus b, or 8 plus 4, and then we can see out the sum to the screen again and drop down a line. And when we run this, well, there's 12, in other words, a plus b, or 8 plus 4. So that is correct. Now, subtraction is just as easy. So we can create this integer variable d for difference. And we can say that d is going to equal a, or 8, minus b, or 4. And so a minus b, or 8 minus 4, should just be 4. And when we see out d to the screen, that's what we expect, is a 4 here. And when we run this, well, there you go. There's our 4. Now, multiplication shouldn't be any surprise. Let's create this integer p for product, and we'll say that p equals a times b. And we're going to see out p to the screen and then drop down a line. And so a times b is, well, 8 times 4. Well, that should just be a 32. And when we run this, well, there you go. There's our 32. Now, division is a little finicky. So let's explore this a little bit. Let's create this integer q for quotient. That's the result of a division problem, right? And then let's just say that a divided by b is going to be our division problem. In other words, 8 divided by 4. Well, easy enough. That should just be 2. And then we can see out, well, q to the screen here, and then drop it down a line. And when we run this, well, there you go. There's our 2. What's so finicky about it? Well, to illustrate the finickiness, let's make this, say, a 10 now, right? So we're doing a divided by b, which is, in other words, 10 divided by 4. And so when we do that, well, 4 goes into 10 2 times, remainder 2. Or in other words, 2.5 times. And so when we run this, we should get 2.5. And when we do, well, we still get a 2. We don't get a 2.5. What's going on here? And so let's sort of trace our code and think about it for a second. So we have this integer q, that's the result of this division problem, and well, that's it. We have this integer here. How are we going to print out an integer and expect to get a 2.5 when we have an integer? Because, well, integers are never 2.5s. They're always whole numbers. And so that's why we got a 2, because, well, we're dividing integers here and we're storing it within an integer. So let's change this integer q, say, to a float q. And now that this is a float, well, this q down here should be, well, 2.5, because, well, wait a second, it's still a 2. Well, as it turns out in C++, in order to print this q out and expect it to be 2.5 or 2.5 or something like that, you need q itself to be some sort of floating point data type, like a float or a double or a long double. And then you need one of these at least, either the thing being divided or the thing doing the dividing. You need one of these at least to also be a float. So we've made q a float. Let's make a a float, and let's see what happens. We'll leave b an int for now, and let's run this, and there's our 2.5, because, well, the result, the thing being printed out, q, is a float, and a is a float too. At least one of these things was a float. And so, well, let's go back to having a as an integer. Well, that should give us an integer result again. But if we change b to float, well, at least one of these things over here is a float, and q is a float, so this should pop up as a float result. And, well, there you go, 2.5. Now, if all of these things are floats, no problem. There's no conflict here. It's just all floats. You have the result, q, well, that's a float. A, the thing being divided, well, that's a float. And b is also a float. So it's all floats. So, yeah, there's no conflict of data types here. So 2.5, of course, because all of it's a float. Now, if a and b are both floats and we change q back to an integer, well, we'll just get an integer again, because it doesn't matter if a or b are floats. If q is an integer and we're printing q out to the screen, we're just printing off an integer. So once again, and we went through all the combinations here, once again, you know, q has to be a float in this scenario, and at least one of these things has to be a float, right? But dividing integers and getting a whole number, even if there should be a fractional, you know, result, has its point. Now, remember back in, you know, early school when we were learning long division, and you did stuff like 4 goes into 10. Well, you did it like this. You didn't come up with a 2.5. You came up with a, you know, 2 remainder 2. You know, 4 goes into 10 times, 2, or 4 goes into 10 2 times, with a remainder of 2. And so that's sort of the point of integer division. So when we make all of these integers, well, of course, we're just going to get an integer result here, and that gives us our 2. But how do we get our remainder? So there's our 2 there. But how do we get our remainder? And so how we get our remainder is through what they call the modulus operator. And so let's create an integer r for remainder, and we'll say that r is going to equal a, and then you put this percent sign, that's the modulus operator, a modulus b, or a mod b for short. And when you run this and print it out, well, that will give you your remainder. And so we should see here that the result of 4 going into 10 will be 2 remainder 2. And so let's run this, and there you go. It's 2 remainder 2. And so to do a different example, let's do 10 divided by 3, right? And so this should give us 3 remainder 1 this time. And when we run this, well, there you go, 3 remainder 1. So easy as that. That's the modulus operator. So this is where I'm going to stop here, just with the addition, subtraction, multiplication, which are all straightforward. Division, which is a little nuancy, but it's not that hard. You just have to have your result as a float and at least one of these values as a float if you expect a float result. And then otherwise, you can keep it all as integers if you're expecting some sort of even numbered return. And I don't mean even as an even and odd, I mean a whole number return. If you're expecting some sort of whole number return, fine, you can keep it as an integer, or you can keep it as an integer if you want to do math like old school longhand division style, where you get results like 6 remainder 4 or something. Okay, see you in the next one.